So let's get started. So suppose you are calling a Fortran function from within your scheduled function call. Then eventually you'll end up in
I'm sorry. Yeah, good.
exactly. I figured this is too small. Oh, I see. This one. Yep.
Yeah, that's better.
Then eventually you'll end up in a Cactus function called CCTK call function. Those of you who have ever written a driver will have seen that one. That actually calls out to the actual user code. And it makes a case decision, basically what's the language of your scheduled function with this f data type. And I don't even quite know what these two are. They might be specialized one in shutdown and startup, who knows? Maybe they're not even used anymore. But normally you're in function standard, and then it distinguishes between your language of implementation, be that C or C++ or Fortran. And as you can see, if it's just C, basically gets the function pointer that you're given, and it directly calls you passing data, which is CCTK arguments. If you're in Fortran, then Fortran functions aren't just passed CCTK arguments the way that C functions are. In particular, CCTK arguments for Fortran is actual individual variables. It's not just CCTK GH, because in Fortran you don't actually have pointers, at least not in Fortran 77, that you could use. So instead, there needs to be something in between, which puts in all the grid functions, all the grid scalars, everything that you're accessing that's in the grid hierarchy as actual explicit arguments into the Fortran function call, and then calls that Fortran function. And if you've ever tried to, say, attach GDB to, say, GRHydro or some of the other large Fortran codes, and you tried to let it print out what's the arguments to that function, it may output them. It might also crash, because apparently GDB is not designed to handle Fortran functions that take thousands of function arguments. So where this happens is here in this Fortran caller helper function. That happens to be a auto-generated function that does all of that for us. So is everybody still with me? So there is a level of indirection. You come from this C flash, you call an automated wrapper that puts all the Fortran arguments in there, and then you're in your Fortran code. Now, I don't think I need this one this big. This is what this wrapper looks like. That's in principle auto-generated code, and I've taken the one for the quasi-local measure Storn, just because this is the one I actually care about, but any Fortran code will look the same. This looks suspiciously small, right? You can see it has 6 lines, and all it really seems to do is it takes the Fortran function pointer, f pointer here, and then it has this macro pass quasi-local measures C to F, which takes CCTKGH as an argument. And you can already guess that that macro must be horrible because it must expand to thousands of arguments. And that's exactly what it does. So this macro is the one that does all the tricks and expands to it. Now, so far, everything is fine. The problem occurs when you look at what this macro does, somewhere in its guts, it needs to get the pointers to the memory regions that are the actual grid functions. So when you have whatever you have the labs or so, that's actually a pointer to the grid array in memory. And that's what you need to pass to Fortran. So you need to somehow get this. What you at that point don't want to do is don't want to go and ask the flash, what's the pointer for ADM-based : labs, and do that every single time, because that's a string lookup with a linear lookup in the string, which is really slow. Instead, it's much faster to first get the variable index, which is just a number. And with that number, you can just index an array and get back your pointer. So that's much faster. For that, though, you need to know what that index is to pass that on. That index is only known at runtime, not at compile time. So you can't pre-compute that. So what used to happen in Cactus, both the C and the Fortran interface, is that there is a couple of static variables that are hidden in these macros that record the variable index for all the variables that you're using. They start off being initialized as -1 at compile time. Then at runtime, the code comes in. It checks, is it still -1? If so, it'll call CCTK var index exactly once to get the variable index for, in this case here, the quasi-local measures 3 determinant variable, and then it stores it in the static integer. And because it's a static integer, it retains its value over function calls, right? That's what static integers do in C. And in Fortran, this would be the safe attribute to a variable. And that's what it does. And that's great for the initial cactus. The downside is these static integers, because they're shared and they're persistent, they are actually shared between multiple threads. And therefore, you run into a race condition that when you call a scheduled function in a multi-threaded manner, which CarpetX does, then the first thread comes around, it sees that one is -1, it calls the lookup function, sees the kvar index, and it sets the variable here, and then it continues. And if that was what actually was happened, and your processor has cache coherency so that multiple threads see memory consistently, then everything would be fine. The worst case scenario, say, you would set the same variable twice. If multiple threads come in, they all see it's -1, they all look the variable index, they all set it. The problem is nothing in the C compiler says you need to do it this way. The C compiler is fine to see a -1, replace that -1 by the value 42, do something else, and replace 42 by the actual result. So that's where the race condition is coming in, that you can't
I'm
really
I'm
have
I'm sorry. 42 is what? Just some random number?
just some random number. Yeah. Or
Roland,
it
I have a
could,
question.
yes.
Might be a naive question. So why can't you just initialize them all and like, in an initial step, you just run it in a single thread, you initialize or you change the value of all these static variables, like you populate the indices and you make sure that you do that in a single thread, and then that should propagate to the other threads, right? So from that point on, if you run something multi-threaded, then they would, when they look at the static variables, they would see the things that you've populated in a prior step. Is that right?
That is correct. That's more or less what the solution actually does.
Ah, okay.
So it can't do exactly what you say, in that these static ints are declared inside of the wrapper functions. So they're not accessible if you're not in the wrapper function itself. So what you would have to do is you'd have to actually call your scheduled function once from a non-threaded environment just to populate these, and then you're good. And of course, this is not supported anywhere. Or I guess you could, in principle. The Flash could have called the wrapper with a dummy that just returns. I think that would have been an option. The actual solution that I had adopted for the C ones is slightly different in that I basically set up a gigantic list of all the cactus variable indices in a struct that is curl away, and I do that at the beginning of the cactus runtime. And then all of these things, instead of actually looking anything up at all, they just refer to the pre-populated array, and they know they don't have to do anything else with it. It also gets rid of a couple of hundred if statements. But yeah, it's essentially that solution.
Okay, thanks.
Right? Okay. So is everybody still kind of with me here? Okay, good. So so clearly this is the unacceptable piece. Now I'll just show you basically what the commit looks like. And that's basically going to be it. But Lucas more or less stole my thunder because essentially that's what it's doing. All right, let me share. Hope I can actually share this one. No, this is my email. I don't want to share my email. I want to share this one. Okay. Is that readable to everybody?
Yes.
Okay, good. So that's just the Git history of the proposal that actually Steve is looking at right now. If I can make this a bit different. Come on. So it's the master branch. And we are basically looking at this particular commit, the one that says remove static variable and group indices from Fortran wrappers. What I've shown you so far was all C code, either handwritten or auto-generated. Because if I want to change this, I have to actually change the code that generates the auto-rated code. And that's in a Perl script called gridfunctionstuff.perl, which does pretty much everything that has to do with CDK arguments. And if you look at this in detail, then let me see what I can show you. I think this one doesn't change. So this is basically the wrapper that you can see, and you can see there is this pass C2F thing with $thorn is your Thorn name, and then the dash U, \U and \E are Perl magic that makes things uppercase. But that's basically what it does. These two red ones used to declare the static integers and initialize them. And that's what the thing that wasn't thread safe. So these are removed. And we have to change whatever that passing function here does. I don't think I have the change of that one visible necessarily. We don't need this one. Not this one. No. Okay. So the passing one eventually calls 3 sets of helper macros. One called pass reference that passes the actual grid function pointer by reference or pointer, right? Then because this is Fortran, you also have to tell it what's the size of the arrays, because Fortran other than C actually knows about the array sizes. So you need to pass these as extra arguments. And group size as well. And I think one of them is the vector length and the other one is the 3D grid size or so. And if you look at them, then they used to refer to these CCTK group num variables, which were the static ones that we had initialized before. What it does in the end is it replaces that CCTK group num local variable that we had defined by an access to the global structure CCTKi group index or name dot group, which we populated at the beginning, and then everything is fine. And the important bit is that this group here gets initialized once at the beginning, and then afterwards it's read only, and then it's fine to do that. And while we don't actually know what variable index that group will be at compile time, we do know at compile time all the possible groups that could ever exist because we know what's an interface.ccl. So that structure will have many entries that are -1 because the group doesn't exist for your current run, but that doesn't matter. We can still initialize all the variable indices correctly. And as a side benefit, this means we don't have any if statements anymore in the actual function calls. Let me see, do I have anything else that I'll show you here? I think that's pretty much it. The 3 replacements are more or less the same. They all just replace access to that constructed variable name. For those of you who do the C preprocessor, the # mark turns the variable into a string, which you can then concatenate. No, the # mark
token
concatenates
yeah.
the variable of the name of that variable with the symbol up front. So that also goes away. Makes it, well, it hides it behind disjoint tokens, which is more or less the same. Okay, and that's more or less what this does. If you wanted to see where the actual assignment happens, it's kind of in here. Let me see. That declares the group. You can see it's just a bunch of integers. And then I have an assignment somewhere. Not this one. What? Where's the assignment? Oh, there. So it's relatively small. There already is code that does that for C. So all I do is I do this again for Fortran. Basically, I keep track of the group that belongs to a particular variable. So I get the group name. This is it's just C code, Perl code. I check have I already handled that particular group just because I iterate over the variable name. So I see the same group multiple times. And then if I haven't seen it yet, all I do is I initialize the group variable calling CCTK group index on it. And that's basically it. So you can see it's a relatively small change in the end, but you have to work your way through a couple of layers of preprocessor macros, auto-generated C code, and other ugliness. Okay, so does anyone have any questions on any of this? Was this too detailed, or was this at least somewhat illustrative of what might be going on?
So how does the new generated Fortran interface look? I mean, you showed us the old one, right?
I actually showed, I think I might have shown you the new one. This is the new one. Let me switch over. Share. So this is what the wrapper looks like, the new one.
That's the new one. Okay, what
That's
does
the
the
new
old one look like?
It had two more lines. It had to declare static variables and initialize static variables.
I see.
The major change is basically that the constituents of this pass macro here changed.
I see.
And because I already had done almost all of the groundwork for the C code, all that really changes here is that I change a concatenation for these local variables, or I change the local static variables out for the, I remove the local static variable access and replace that one with the global list of groups.
So one of the things that's happened with Fortran, I guess, that we will probably never update for is that there's now an ISO compliant way to link Fortran and C rather than this thing that Paul Walker reverse engineered 30 years ago.
Yes. You could, in principle, theoretically, I guess, now try and do that and pass these DKGH to Fortran functions.
Yeah.
And then set this up.
Anyway, it's probably not worth doing.
No. you might see optimization potential, right? So if you, because we are still, so there's one wrapper per thorn, right? Which means that wrapper always passes all the possible variables that any function of that thorn might possibly use to that scheduled function. And if you're looking at something like GeoHydra, you are passing, I think it's on the order of 1,000 variables. So you're pushing 8 kilobytes of data onto the stack because you're pushing 1,000 pointers each scheduled function call.
Yeah.
And the compiler has no way of optimizing this because it doesn't know whether or not you're using these variables. It has no idea. In the C style code, and in particular, if one uses Steve's reads and writes and the checked macros, then only those variables that you're actually using will be initialized. Everything else, the compiler can either realize, yeah, you're setting up this pointer, but you're never using it. I might just as well optimize it away. Or it's not even ever set with the checked macros. So that could be a possible optimization. But I don't know. It really depends on whether the 8 kilobytes that you're pushing onto the stack is notable or not. And I think you'd have to create parallel structure records in Fortran and in C.
Yeah.
And
we won't do that. So
no. I mean, if somebody finds that it actually is slow.
Well,
right?
If somebody actually wants to use Fortran.
Well, Peter is occasionally around.
Yeah.
But yeah, there is this, right? So there is definitely a inefficiency that's going on here that one could avoid. I don't quite know if you can do it in every single situation. So in Fortran, right, you have to give it, what's it called? You have to, when you have a 3D grid function, you actually have to declare it with the proper dimensions. And you can do that if the grid function and then the dimensions are coming in a subroutine arguments, right? So that's the standard way. You say array, and then the 3 sizes in the 3 directions, and then you have a Fortran array declaration with the 3 sizes in there, and everything is happy. If you switch that over to the way that C works, the only thing you passed is the CTKGH function, and you have to get the array sizes out of that. But that's a function call. And as far as I know, in Fortran, I can't make any function calls until after all the variables are declared. So there is going to be a little bit of work that you have to do, I suspect, for this, if you wanted to. Or you can have one wrapper per scheduled function.